This is the Poison Terminator podcast. My name is Carlo Diolan. There are several first aid treatments for jellyfish envenomation. This generates a lot of confusion in members of the public about which treatment to use. My guest, Dr. Angel Yanagihara, decided to verify with a study which of these treatments is more efficient for lion's mane jellyfish envenomation. Her study was published in the journal Toxins. Dr. Angel Yanagihara is an associate research professor at the University of Hawaii at Manoa. She has led the Pacific Cnidarian Research Laboratory for the past 20 years. Dr. Yanagihara's research program ranges from studying the biochemical composition of jellyfish venoms and how they work to studies designed to improve first aid and clinical management of jellyfish stings. Welcome to the show, Dr. Yanagihara.
Thank you very much for this invitation.
Before we get into the study, let's talk about some basic aspects of the jellyfish so we can better understand the study. Explain to us what are lion's mane jellyfish.
They are one species of freely swimming so-called medusozoa, and these animals belong to the phylum Cnidaria, which includes corals, anemones, and the medusozoa. All members of the phylum Cnidaria contain stinging cells, some of which are penetrant. These are called cnidae, and the penetrant cnidae are called nematocysts. So these jellies also belong to a class called Scyphozoa. So lion's mane or cyanea are commonly found in colder waters around the world. So they're a type of jellyfish, and they have these explosive stinging cells, penetrant cnidae called nematocysts, that deliver venom.
How does the venom induce its toxic effects?
The venom basically is a complex cocktail of digestive proteins and peptides and small molecules built to take prey such as fish and rapidly digest and absorb them. So these venoms, when they are injected into human flesh, have various effects on our flesh, but typically include inflammation and some tissue destruction at the site of the sting.
Now let's get into the study. What were the first aid treatments that were tested in the study?
I think, first of all, one needs to be very careful in the language. The word treatment should be reserved for things which authentically improve outcomes. So when we examine first aid approaches, many of these have been notoriously put forward in the lay press, such as perhaps urine, use of urine to treat a sting, Coca-Cola, ice, etc. But whereas the authentic intent may be to treat the sting, the outcome is not necessarily the same as the intent. So when we examined these various approaches, we were looking to see, do they authentically improve outcomes, or do they in fact make matters worse?
Which first aid procedures were shown to be effective?
So the other important thing that is often missed with regard to optimal first aid for the response to jellyfish stings is that what one needs is at least 2 steps. So because when these tentacles make contact with human skin, only a small fraction of the explosive cnidae actually discharge and penetrate the skin to deliver their venom, a great number of these are left on the skin undischarged and intact, but they are like ticking time bombs going to discharge at some point. So the first step of appropriate first aid should be to remove these undischarged cnidae and to irreversibly inactivate them. So we found the most effective way to do that was with a vinegar rinse, or new technologies that include vinegar as well as urea and other actives. So the first step is to inactivate these stinging capsules and remove them. Unfortunately, we found that while well-intentioned folks have been surmising that seawater would be an appropriate approach, seawater was actually one of the worst approaches because seawater does not inactivate these undischarged explosive nidae. It only moves them around, and then they go on to discharge later. Whereas vinegar irreversibly inactivates them. It causes a structural change in these tiny, extremely elaborate architectural microscopic devices that fire off. And when they're exposed to vinegar, the collagen capsule becomes hygroscopic and swells a bit such that it now is not capable of effective discharge. Sometimes it ruptures, the tubule comes out, but again, it's not capable of injecting the venom. So vinegar was far and away, or vinegar-containing approaches, the best first step of appropriate first aid.
What's the best thing to do if we don't have vinegar?
Well, so the second step of first aid after cleaning the site is to inactivate the venom that's already been injected into the tissue. So if one doesn't have vinegar, then perhaps one could just rush off to the second step. And we found of the low-cost and no-cost options, the best outcomes occurred after the application of heat. So 42 to 45 degrees Celsius for at least 30 to 45 minutes. Interestingly, whereas our human proteins in our skin are rather heat tolerant, the proteins that comprise these ancient marine jelly venoms are exquisitely heat sensitive. So it doesn't take very hot water, but it does take a good amount of time. So 45 minutes at 45 degrees, which is safe hot water, it's not scalding, will irreversibly inactivate this venom. And if one didn't have the vinegar, then going on to the second step, in our data assessment of our tissue models, shows the best result.
What should we use to remove the tentacles?
Well, again, vinegar or the vinegar-containing new technology, the Sting No More spray, is the best way to get rid of the tentacles. Great care should be taken. If one didn't have vinegar on hand, just using gloves or a towel or sand or a credit card to scrape it off, all are horrible options because basically they cause massive increase of discharge. The live undischarged nidae and the tentacles are all exquisitely sensitive to any kind of site pressure. So scraping with a credit card is one of the absolute worst things that one could do. So if one didn't have vinegar, then again, to submerge it in hot water might be the best option, but far better than that is to be prepared. If one is going swimming in an area in which lion's manes occur, bring a bottle of vinegar. First aid stations should all have vinegar. This should be a question of preparation rather than having to be reactive and deal with little or no proper options.
Tell us what can we expect after a lion's mane jellyfish sting? Well,
the effects of the venom have to do with the dose that is injected, and that has to do with where on the body one is stung, as well as the age of the victim. So in stings of a small child on the thin skin of the neck or inner surface of the arms, the venom load can be quite high. So the signs and symptoms that occur after a sting likewise are related to the dose. So a 1-foot tentacle contact on a 3-year-old child could lead to signs and symptoms far more severe than the same length of tentacle on the thicker skin of an adult man. That said, the range of outcomes would be from mild irritation and some small bit of pain to extreme pain with obvious reddening and swelling inflammation at the site, all the way to what is called Irukandji syndrome, which is a complex constellation of systemic symptoms, including sweating, nausea, feeling of doom, and can, in fact, even lead to cerebral hemorrhage, has a hypertensive and a hypotensive phase to it. So there's a range of signs and symptoms that could follow exposure to a lion's mane sting.
How long should an envenomation be monitored?
For a child, definitely at least 2 hours to ascertain that breathing is not labored and the pain is being managed. For most adults, I think that they can pretty well self-report their status. But again, if any systemic symptoms are noted, nausea, sweating, irregular heartbeat, difficulty breathing, they should seek medical care right away and be alert and watching for that within 4 hours of a sting.
Are there any long-term consequences to a jellyfish sting?
That's a great question, and I get lots of email from around the world from folks who had severe stings and report a whole group of various long-term outcomes that they perceive were linked to the sting. I haven't seen any clear retrospective study statistically powered that would correlate these as cause and effect. But I think this is something we should, keep our eyes open to, and I have collected these data over the years, and I'm looking for some kind of general correlation, but at present, some of the general complaints are long-term type of sciatica, these kinds of sporadic neurologic signs, etc., even sporadic thrombocytopenia. So this isn't clear, though, at this point that we can truly correlate those.
Can a dead jellyfish induce any effect on our skin?
Well, when one describes dead in terms of a jellyfish, the normal definitions don't hold up, because these stinging cells that fill the tentacles can, in fact, be freeze-dried and kept in the lab or in a freezer for 40 years and still be alive to the extent that they could still discharge and inject venom into a target. So the fact that the animal may no longer be pulsing in the water and is dried on the beach does not necessarily mean that there's no sting hazard present.
Why did you decide to do research on jellyfish?
Well, I was just a classically trained biochemist interested in membrane enzymes and electrophysiology and these kinds of cellular mechanisms, until one day when I was stung offshore of Hawaii, Oahu Island, swimming my mile morning swim, and I ran into a whole group of these. Basically, I was over a third mile offshore, and I had such a severe sting that I had trouble breathing, and I was definitely worried that I was in danger of drowning. My lungs seemed to be filling with fluid, and all the sting site felt like burning needles injected into me. So it got my attention. I did fortunately make it back to shore, and I was cared for in an ambulance. But after I was able to, I did a literature search to find out about the biochemistry of this extremely impressive and unnerving venom, and I found that no work to my satisfaction had been published, so I wrote a proposal just really out of somewhat of a sense of humor to do this kind of work, but not being in that field, I didn't think it would have a chance of being funded. When it was funded, I was happily surprised, and that sort of turned the corner of my career and led to the last 20 years of my work.
Can you describe the feeling of a jellyfish sting?
Yes, I would say it's excruciatingly painful. The box jellyfish stings in particular are notorious for this fiery pain. The other aspect, which is really quite concerning, is it seems to cause a classical anxiety response, and the biochemical basis for this is what's called a catechol surge, and so that comes with an attendant feeling of doom. So it's not very helpful to be a swimmer offshore with diminishing respiratory capacity and a convincing feeling that you're going to die, with all the rest and the extreme pain. So it's a horrific set of events, and my heart goes out to children who have to experience such a thing, because this is definitely the worst experience that I had ever had.
How do you educate the public on such an important subject?
Well, as a scientist and as a university research professor, the first avenue of our communication is through academic publications. That said, because this is an area of critical interest for the general public, we are approached oftentimes by the lay press, and we've been the work has been featured in various documentaries, National Geographic, Nova, BBC, Canadian and French documentaries, and various magazines. But it's difficult because so many important and professional websites that are built to advise emergency caregivers, even the London-based National Health Services gets it wrong, and they put out well-intentioned, stale, old advice which has never been validated, such as applying shaving cream and scraping with a credit card and then applying ice. In statistically powered, evidence-based research, we find that all of those things are completely counterproductive and lead to far worse outcomes. So revisiting even medical school textbooks, which seem to want to borrow things from the treatment of bee stings and advise even a baking soda poultice over the sting, which again leads to a worsening outcome. All of these things need to be revisited with the lens of evidence-based, peer-reviewed, published work. And unfortunately, there is not very much scientific literature that evaluates these so-called first aid approaches to ascertain whether or not they are useful or in fact counterproductive.
Dr. Yanagihara, I would like to thank you for giving us important facts on how to protect ourselves from jellyfish stings.
You're welcome. Thank you for the opportunity.
Dr. Angel Yanagihara is an associate research professor of the University of Hawaii at Manoa. She's also the principal investigator of the Pacific Cnidarian Research Laboratory. That's all for today. I'm the Poison Terminator. I'll be back next week with another episode. Have a great day.